Welcome, athletes, to 4.3 Maxima and Minima. And so in 4.3, we're going to talk about, we're going to spend a couple of days on this. One day we're going to talk about local extrema and critical points. So local extrema and critical points are kind of all the potential peaks and valleys, the highs and lows, and also the points where we might have some undefined values for our derivative. And so we're going to find all of those, and then in the next lesson on part 2, we're going to talk about absolute extrema, like where the highest of highs are and the lowest of lows, basically. All right. So when we have a function, and here we have a graphical representation of a function, right? We have a bunch of different extrema. So extrema is the plural for extremum, right, which is one extreme, and so you can also say extremes and extreme. So you don't necessarily have to say extremum and max and extrema. You can say extreme and extremes. That's okay and accepted generally. The same with minimum and minima, or maximums and maxima. Like the plural you can say is maxima, or maximums is also acceptable. So, but a lot of times in textbooks you'll see maxima and minima. And so anyway, so looking at a function like this, if we kind of go around, we can see that there's a few peaks, right? So those are critical points, and they're also local maximums or maxima, right? And so those are high points, right? And one of them is the highest point, right? So this is an absolute maximum, because it's the highest the function goes at all, right? All right, where this over here, both of these are local, but this is a local max, and this is also a local max. Okay, so they're both local, but only one of them is absolute, right? And then here we have a local minima, right? A local minimum, I should say, because it's singular, right? But that's not an absolute minimum, right? Because this function goes down forever, and so there is no absolute minimum. Okay, and that's the case. Sometimes the function doesn't have an absolute minimum or an absolute maximum, or neither, right? It could be neither. So in the case of an odd function, you're going to have a couple local values, local extrema, but you're not going to have an absolute, because it goes up forever and down forever as far as the end behavior. Okay. All right. So anyway, that's kind of the idea of local mins and maxes, are that we want the peaks and the valleys, right? The peaks and the valleys. And critical points are a little more broad than that, but the peaks and the valleys a lot of times are what are important, right? Because if our function represents the value of a home, or the value of some type of real estate property, then we want to try to find those peaks and valleys, right? Because we want to buy low and sell high, right? And that's the way we can maximize our investments, right? And so anyway, so those are the kind of things that are important, is finding local mins and maxes, and then absolute mins and maxes, because that can help us to make some good decisions based on whatever that that graph represents. All right, and just to here's the definition of local max and mins. So basically, we have an interval I, right? So some interval, and a local maximum is where you have a value at C of the function, right? An output at C that's greater than all other outputs in that given interval, right? So here, like, we can pick an interval, and this is the highest point in that interval, right? That's greater. There's a point here greater than any other point in that interval, right? So if you can find any interval where there's a point that's bigger than any other point, that's a local maximum, right? And the same thing with the local minimum. It's the same thing except for it's the it's a place where it's the lowest point, right, on the whole interval. Is basically what that says. All right. So and then a local extremum is a singular max or min, right? So it's if you have a local maximum or a local minimum, both of those fall in the category of an extremum.